The two holes found in the prongs of a cord cap serve a specific and important purpose. They are designed to accommodate a locking ring. This locking ring plays a crucial role in securing the cord cap to the electrical cord itself, preventing accidental disconnections. Accidental disconnections can be hazardous, potentially leading to electrical shocks, fires, or equipment damage. The locking ring is usually manufactured from either plastic or metal, depending on the application and the cord cap's overall design. It features two small tabs, or protrusions, precisely sized and positioned to fit snugly into the holes on the prongs of the cord cap. When the locking ring is properly installed and tightened, it creates a secure and reliable connection between the cord cap and the electrical cord. The act of tightening the ring causes the tabs to engage with the prongs, effectively locking the cord in place. This locking mechanism is an important feature for electrical safety. By preventing the cord from easily being pulled out of the outlet or appliance, it reduces the risk of exposing live electrical contacts. Such exposure could lead to electrical shock injuries. Furthermore, loose connections can generate heat, increasing the risk of electrical fires. Therefore, the simple locking mechanism contributes significantly to preventing both electrical shocks and fire hazards. In many areas, the use of cord caps with locking rings is not just a matter of best practice, it's mandated by local electrical codes. These codes, often based on the National Electrical Code, or NEC, specify requirements for electrical installations and equipment to ensure safety. Compliance with these codes is essential for preventing electrical hazards and maintaining a safe environment. The NEC is a comprehensive set of standards that covers a wide range of electrical topics, from wiring methods to equipment installation. It is updated regularly to reflect advancements in technology and evolving safety concerns. It's important for homeowners and electricians alike to be familiar with the NEC and any local amendments to ensure compliance. The NEC in Section 210.52 addresses receptacle outlet requirements in dwelling units. It covers the placement and number of receptacles required in various rooms to ensure convenient access to power and minimize the use of extension cords, which can be a safety hazard. The NEC in Section 314.16 deals with calculating the number of conductors allowed in a box. This is crucial for ensuring that electrical boxes are not overcrowded, which can lead to overheating and potential fire hazard. Factors such as wire size, the number of devices, and the presence of equipment grounding conductors are all considered in the calculation. The NEC in Section 250.118 lists the types of equipment grounding conductors that are permitted for use in electrical systems. These conductors provide a path for fault current to return to the source, allowing overcurrent devices to trip and to energize the circuit, thereby preventing electrical shock hazards. Acceptable types of equipment grounding conductors include wire, rigid metal conduit, and electrical metallic tubing. The NEC in Section 406.9 specifies the requirements for receptacles installed in damp or wet locations. These receptacles must be protected by weatherproof enclosures to prevent water from entering the electrical connections and causing corrosion or electrical shock hazards. The type of enclosure required depends on the specific location and the level of exposure to moisture. The NEC in Section 300.11 addresses the securing and supporting of wiring methods. This is important for preventing damage to conductors and ensuring the long-term reliability of the electrical system. Wiring must be properly supported at regular intervals using approved methods such as straps, staples, or hangers. The NEC in Section 110.3 outlines the requirements for the examination, installation, and use of equipment. Electrical equipment must be evaluated by a qualified testing laboratory and installed in accordance with the manufacturer's instructions. It must also be used in a manner that is consistent with its listing and labeling. The NEC in Section 230.70 specifies the location of disconnecting means for service conductors. This is important for providing a means to quickly and safely disconnect power to the building in case of an emergency. The disconnecting means must be readily accessible and located at a point where the service conductors enter the building. The NEC in Section 250.50 addresses the grounding electrode system. This system provides a connection to the earth, which helps to stabilize voltage and provide a path for fault current to return to the source. The grounding electrode system typically consists of a ground rod, metal water pipe, or concrete encased electrode. The neck, in section 408.3, specifies the requirements for overcurrent protection in panel boards. Each circuit in a panel board must be protected by a fuse or circuit breaker that is sized appropriately for the conductor it is protecting. This prevents overloads and short circuits, which can lead to overheating and fire. The neck, in section 310.15, provides tables for determining the allowable ampacity of conductors. Ampacity refers to the maximum amount of current that a conductor can carry safely without overheating. The allowable ampacity depends on factors such as the conductor material, size, insulation type, and ambient temperature. In general terms, the locking ring mechanism enhances safety by preventing accidental disconnections, protecting against electrical shocks and fires, and ensuring compliance with electrical codes.